Hi everyone, welcome to my channel. In this video I'm going to be explaining the types of functions, and I'm going to describe them or give a more clearer definition of these functions using a graph. Now number one we have what we call the constant function. Number one, we have what we call the constant function. Now in a constant function, it is a function where the output value fx is the same for every input value. Now, for example, in an ordered pair, 1 having an output of 2, 2 will still have the same output of 2, and then 3 will still have that same output, and then 4 will still have the same output. That is a constant function. Every input have exactly the same output. Every input have exactly the same output. We can see here in the graph that when x is equals to -1, y is equals to 5. When x is equals to 0, y is still 5. When 3 is equals to 0, y is still 5. And then we have here that when x is equals to -2, y is still 5. So this is the graphical representation of. Number 2, we have the identity function. An identity function, often defined as fx, a mathematical function that returns the same value that was used as its input to itself, effectively leaving it unchanged. Now, do not mind my graph, just follow what I'm about to say now. You can see here that here when x is equals to 1, y 1, x is equals to 2, y 2, x is equals to -2, y -2, x equals to -3, y -3. Now this will be the ordered pair. The ordered pair. Now the ordered pair here is 1, 1, comma, here is 2, 2, then we have -1, or we have -2 pointing to -2, then we have -3 to -3. This is an identity function. This is an identity function. Now another example, we have the Signum function. This is the graphical representation of a Signum function. You can see here the plus x, the plus y, minus x, plus y. You can see the values in each axis, and then you can also see that there is an arrow, like an expression of an equality. Now let me explain what a Signum function is, but first let me give you the mathematical expression of a Signum function. Now this is the mathematical expression of a Signum function. A Signum function can also be known as the sine function. It can also be known as the sine function. Now, since it is known as a sine function, this is the mathematical expression, this is the graphical expression of a Signum function or a sine function. Now we have here 1 if x is greater than 0, 0 if x is equals to 0, and -1 if x is less than 0. Now, you know that for a number to be 1, if someone have a number as 1, 1 is greater than 0. If someone have a number as 0, he has nothing, so he is equals to 0. If someone have a number as -1, -1 is, if x is -1, it is less any number in the number line that is minus, it is less than 0. 0 is greater than -1. A number 0 is greater than -1. If you are owing someone, even if it is 1 million naira, that 1 million naira is less than 0. Why? Because the 1 million naira you are owing is not yours. But if you have nothing, the nothing you do not have is greater than what you are owing. That is the explanation for that. So now I can now say, example, we have sine equals to 1. Sine minus 10 equals to minus 1. Then sine 0. And number 3, we have the signum function or the sine function. Now let me explain what the signum function is. Signum function, you can see here that 1 if x is greater than 0, 0 if x is equals to 0, or minus 1 if x is less than 0. We have here, you can see the graph. This is the graphical expression of a signum function, and this is the mathematical expression of a signum function. You can see here that it is simple to understand that signum of 5 is 1. The signum of minus 10 is not going to be minus 10, but it's going to be minus 1. The signum of 0 is 0. As simple as that. Now, let me explain further. The distance between 0 and minus 1 is minus 1. The distance between 0 and minus 2 is still taken as minus 1. That is the law for a signum function. Now, the distance between 0 and 1 is 1. The distance between 0 and 2 is 2. And the distance between 0 and 3 is 3. Now, the mathematical expression of a signum function states that x is greater than 0 if x is equals to 1. You can see here that x is 1. X is greater than 1 is greater than 0. That is why x is greater than 0. The same thing applies here, and the same thing applies here. Okay, everyone. Number 4, we have the Heaviside, the unit step function. The Heaviside can also be called the unit step function. Now, this is the graphical representation of a Heaviside or unit step function. This is the mathematical expression of the Heaviside or unit step function. And I can see here, just as a graph of an inequality, that the open circle means that the value is not included, and the filled circle means the value is included. Now, here is the before action, and here we have the after the action equals to 0 equals to 1. Now, let me explain this before going to the graphical and the mathematical expression of the Heaviside or the unit step function. Now, the Heaviside of the unit step function is just like a machine, or let's say it is just like a circuit. Before you on the switch, it was at 0. Now, after you on the switch, it is at 1. That's as you before owning the switch, power was 0. Then after you on the switch, power now switches to 1. That is why it's called a unit step. The process where it jumps from 0 to 1 is a unit step or Heaviside function. In a Heaviside function or unit step function has to do with two values, 0 and 1. 0 is the before action and 1 is the after action. And Heaviside function is a function that suddenly switches at a particular time. Now, you can see here that this is the graphical representation of a Heaviside function. Now, you can see here that the values here at 0, you can see here that the values here we have are minus 1, minus 1, minus 3 to minus infinity. Here is plus 1, plus 2, and plus 3. You can see this, and you can see this. Now, if we say what is the value of H2, the value of H2 is 1. You can see here the Heaviside in this from here to infinity is 1. The Heaviside from here to infinity is 0. Now, if we have what is the Heaviside of minus 2, minus 2 lies within the axis, which is the negative axis. So for every negative axis, the Heaviside of then that number that carries the negative sign will always be 0, while the positive is 1. That is just the explanation for an Heaviside function. That is just an expression for an Heaviside function. For example, we have x minus 3 is equals to, we have 0, 1. That is if x is less than 3. And then we have x, we have here x greater than or equals to 3. It's supposed to be 0, but since we have 3 here, this 0 is usually known as the switch point, where it can switch to 1 at any time. Now, that is the starting point or the origin. Now, since we have 3 here, 3 is now the starting point, because we know that if x minus 3 is equals to 0, x is equals to 3. That is the starting point. Now, here, we now have this. Now, for an example, now, we want to input our domain here. Starting from 1, we are going to have x1 minus 3, which is equals to h, minus 2. Now, the Heaviside of minus 2 is 0. Why is it 0? It's because it lies within the region of the negative numbers to the negative infinity. Now, if we have a value where the domain is 5, we input 5 into where we have x, and this is what we have, the Heaviside of 2. Now, the Heaviside of 2 is 1. Why is it 1? It's because 2 lies within the region of the positive numbers to positive infinity. Now, the summary of everything is that the Heaviside, the summary of everything here is that the Heaviside of a positive number is 1, while the Heaviside of a negative number is 0. Thank you. Now, looking at this, we have another type of function known as a modulus or absolute value function. The modulus or absolute value function. Now, if you have a number that is in this form, this means this is the absolute value of 2, while this is the absolute value of x. Any number in this, what it actually means is that this is the absolute value of x. Now, this is the mathematical expression, and while this is the graphical expression. Now, a modulus or absolute value function is a type of function that has to do with the distance between 0, the origin, and any number. Could be a positive number as we have here, another positive number, or a negative number. Now, we know that the distance between 0 and 1 is 1. The distance between 0 and minus 1 is 1. Why is it not minus 1? It is not minus 1 because the distance between two places can never be negative. The distance between USA and Russia, if it is 980 kilometers, it can never be, if it is 980 kilometers, it can never be minus 980 kilometers. Why? Because the distance between 2 points can never and never be negative. Now, you see here, this is the graphical expression, and then this is just the mathematical expression of an absolute value function. It is just about the distance between a number and 0, even if the number that we use to say the number between, even if the number is minus 1 to 0, the absolute value function is 1, not minus 1. Number 6, we have the greatest integer function. This is a graphical representation of the greatest integer function. Now, I'll give you the definition of the term. The greatest integer function is a mathematical function that gives the largest integer less than or equals to a given number. Now, a modulus of x, this is how it is written, but the greatest integer function of x is written in this manner. Now, we have examples here. This is 3.7. To find the greatest integer function, they said that from the definition, it gives the largest integer less than or equals to. Now, this means that the greatest integer of x is less than x.